CBS Eye on the World, I'm John Batchelor with Professor Paul Halpern. His new book is Flashes of Creation, George Gamow, Fred Hoyle, and the Great Big Bang Debate. I met Fred Hoyle from a science fiction book he wrote in the 1950s. I met George Gamow from a book that he wrote about cosmology, 1, 2, 3, Infinity, in the 1950s. I never understood Gamow. I loved Hoyle. So those are my prejudices, but to have them both together is a joy, thanks to Paul's work. So we pick up our story of the son of the pianist at the movies, Fred Hoyle. He arrives at Cambridge through a series of, you can't make this up, debates. He has mentor professors, and he's guided to Cambridge. He arrives at the time of a rich turning of physics at Cambridge. Max Born, Rudolf Peierls, they're building an accelerator. The Professor de Sitter dies, but others come, Professor Price, Professor Dirac, and he wins his PhD eventually in 1939. What did Fred Hoyle think he was while at Cambridge with all these distinguished physicists, Paul?
He definitely wanted to be a particle physicist or a nuclear physicist. Originally, in high school, he wanted to be a chemist. And as a child, he loved astronomy, but he went from astronomy to chemistry. And finally, at Cambridge, he imagined himself working in particle labs and interpreting the information, so interpreting the data. Very, very similar to what Gamow was doing some time earlier. So Gamow would develop models of how nuclear particles interacted. Hoyle had a great respect for Gamow's work and wanted to kind of continue along those lines. And then, of course, in 1939, World War II came along, and Hoyle had to, he got his PhD, but then he had to wait until he could get a professorship at Cambridge, which didn't come until 1945.
He plunges into super secret work, which is radar. He eventually joins in 42 Section 8X RC8. I love these titles. It has no meaning, Paul, but it's wonderfully romantic. And he's attracted to astronomy of population 1 and population 2 stars. I think about this time he buys himself a telescope. What did he make of astronomy and particle physics? Did he think of them as two ends of the same story?
Well, what happened was he went to the United States for a meeting related to military-related issues, and he was interested in talking to astronomers in the United States. That was a fascination. So he decided to speak to somebody named Walter Baade. And Walter Baade had a remarkable theory about supernova explosions being the end results of older stars, very hydrogen-rich stars, very massive stars that meet a catastrophic end and end up in an explosion. And the idea was, from Walter Baade, that there was an earlier generation of stars called Population 2. They exploded in supernova, and their material was distributed around the galaxy, around the universe, and that material was picked up by the more recent stars, such as the sun, and which is why the sun has a lot of other materials in it. And Hoyle thought that was fascinating and developed in 1946 a key paper on stellar nucleosynthesis, trying to explain how all the higher elements are produced step by step, starting with hydrogen all the way up to uranium. And that he sketched the idea in 1946. He further developed it in the 50s with other researchers. And this idea became the basis of the origin of the chemical elements.
We're looking at two large series that have been developing while we're racing through the education of our protagonists. Because telescopes were still discerning the differences between fuzzy stars and near stars, and there was not certainty that the universe was made up of many galaxies as opposed to the one, the Milky Way. This is developing in these same years. So astronomy is getting more articulate as physics is getting more articulate. Just a note here, we have a couple of minutes. And Paul, the reason you're good at this is because you can do in 2 minutes the steady state versus the cosmic egg. Lemaitre, a French priest, I believe, comes up with the idea of what we understand to be the Big Bang, the original moment. He calls it the cosmic egg. that is a competing source with steady state, which is it true that Einstein was an early steady state, early fixed universe thinker that who later changed?
He wrote one paper that was never published on the steady state idea. And a friend of mine, an Irish physicist, Cormac Rafferty, discovered that the paper was an early version of the steady state theory, but it was never published, so Einstein discarded the idea.
Right. Einstein discarded steady state, but Hoyle takes it up. Gamow, was he either or? Did he go with Lemaitre's cosmic egg, or did he go with steady state, or did he wait?
Gamow was firmly in the Big Bang camp. He further developed the idea of Lemaitre and Friedman. So Friedman talked about an expanding universe. Lemaitre also talked about expanding universe, added the part about the primeval atom, and then that became what's now known as the Big Bang theory. And Gamow said, well, that theory could be used to explain how all the elements come about. So Gamow had a competing theory of the elements, which said that all the elements were produced in the hot early universe during the Big Bang.
Yes, there are some difficulties here. One, they did not have a good estimate of the age of the cosmos that we now understand as 13 is it 13.4 or 13.8, Paul? I can never remember the difference.
13.8.
13.8 billion years. They were dealing with numbers anywhere between 2 billion and 10 billion. But we'll turn to that controversy. The book is Flashes of Creation. George Gamow, Fred Hoyle, and the Great Big Bang Debate. Paul Halpern is the author.